Wow, this looks intense. I have this lamp that I've been using to signify work time, so it connects via magnets. These little these magnetic spheres attached to strings. Basically, they pull something on the bottom that triggers. Yeah, so I just kind of this basically just means that the shop is open. I'm inspired by Tony Stark, so imagine Iron Man 2, Iron Man 3. Imagine his shop, all the toys, the dummies, the AI, everything. So I'm super inspired by that. So the idea that shop is open, ready to at least do a little something tonight. I was actually on this morning doing a little recording session. I'm gonna move that. So I left off finishing on the longest substring with maximum k distinct characters. I forgot to do a complexity analysis of this problem. So I'm gonna do one real fast and call it a day. Actually, I'm gonna do probably a problem too, because I think I should do that. Just do time complexity. So the explanation here is what? We've got n for sure. The while loop constant time. I'm gonna just say big O n. I might check that looks at each character. Now in an interview, I might give a more what's it called, robust explanation. But I mean, this feels quite similar or quite simple. Let me take a look at the actual problem. Yeah. Okay, cool. The above algorithm is composite n, where n is the number of characters in the input string. The outer for loop runs all characters in interval while processing. Only once. Yeah, only once. The algorithm space complexity is okay. Why? Big OK. As we're storing a maximum of k plus 1 characters in the hash map. Oh. Yeah. That makes complete sense because we're only going to store at most k characters. I shouldn't get lazy with it because, right? In the, I'll say frequency for domain knowledge. Okay. Sounds Gucci to me, bro. Next freaking problem. This is fruit baskets. I kind of like fruit baskets, to be honest. This is a nice one. This is medium. Medium. Problem statement. Now this one I do not have, what's it called? I do not have a fancy explanation for yet. I'm actually starting from scratch on this problem. So, and by scratch, I mean I haven't seen it this time around, so I have to redo it. I have an example here of kind of how I would do it, but I'm going to start from scratch and just develop a new solution. Yeah, let's do it. So we have our fruit basket problem. Cool. Oh, wait, what? That's nuts because basically it's saying that I have to have... Well, that's crazy. I didn't know that. I wonder if there are multi-line strings. Sorry, multi-line bold. Okay. I mean, not across new lines, I'm noticing, but okay. Is there an extra thing here? Excuse my formatting challenges. Okay. Double checking OBS. Looks like it's tracking. The last video I posted, my second archives episode, I straight up I was using the beta screen capture for Mac, which is in beta. I had to upgrade my Mac version just to use it. I had to go all the way. I think it's, what's it called? Oh. Well, this looks weird. Oh. They changed it. The view of it. Cool. Anyway. Yes, so I had to switch up. I just did a software update. What do you mean? And this is completely unrelated, but I'm just in it anyway because I'm cool. Wow. Pro video formats. I don't care about that. So they moved it more to like a settings, like iPhone settings. Interesting. Anyway. About cool. So I basically had to upgrade to Mac OS Ventura to be able to use this Mac screen capture, but it actually froze halfway through mine. I say halfway, but it was like a solid chunk of the way in, or no, early on in the video for a solid chunk of time. My phone's here and I'm getting distracted by it. For a solid chunk of time, it just wasn't recording anything. It just captured a still image of like this. I was talking, I was typing, and it just wasn't recording anything. Anyway, so our problem is what? Fruit baskets. Fruits into baskets. You're visiting a farm to collect fruits. The farm has what? The farm has a single row of fruit trees. Whack. You will be given 2 baskets, and your goal is to pick as many fruits as possible to be placed in the baskets. You will be given an array of characters where each character represents a fruit tree, a single tree. So one array is the one row of fruit trees. The farm has the following restrictions. Rules. Each basket can have only one type of fruit. There is no limit to how many fruit a basket can hold. So a basket can have one kind of fruit, like A. They could have 100 A's. Cool. You can start with any tree, but you can't skip a tree once you've started. I forgot to add a line. I was looking for some kind of like write this function that does this. And here it is. Okay. Oh, this is a list of things. Hold on. Can I do that? Oh, I can. That does make everything look weird though. Take these out. Try this. Beautiful. Is that right? 3 things? Cool. I'll do 1, 2, 3 because that seems more appropriate here. Huh? Oh, that's not what I thought it was. But it looks good though. Sweet. Okay, so each basket can have only one type of fruit. There's no limit to how many fruit a basket can hold. You can start with any tree, so any point in the array of characters, but you cannot skip a tree once you started. So basically, oh, I think I got this wrong last time. Understanding it was hard. You can pick exactly one fruit from every tree until you cannot. Or for example, you will stop when you have to pick. Oh, let's look at that. it's I think it's taking that space to be like a line break or something. You'll stop when you have to pick from a third fruit type. K. So there's an input. I'm actually really sleepy now that I'm starting this problem. But we're gonna try to get at least part of the way through it and pick up the rest tomorrow morning. Going over to Jazz's to eat delicious food. Could empty my stomach before that. Be a lot of good eats. Paper towel for wiping because I want to protect my hands from nastiness. All right, so I want to touch the whiteboard with me. So I can write down thoughts freely. So we get this array of fruit trees of a specific type. So I'll start with this example, the first example. So I'm writing down A, B, C, A, C, okay? And we want to pick, what's the goal? Write a function to return the maximum number of fruits in both baskets. The maximum number of fruits in both baskets. Cool. So this is pretty similar to our last problem, which was longest substring with maximum k distinct characters. And I'll explain why in a minute once I set this problem up. We have a list of inputs, or the input is a list of tree types. Nothing else gets passed in. So this is similar to the last problem because we can only have at most 2. So our k before was some number, right? The k was our limit. It had to have it, or it was our requirement. It could have at most k distinct characters. So what's cool about this problem is that we can probably do something similar to the last one. Meaning we can do a frequency dictionary. So if I understand the problem correctly, the point is to find a place where, or I guess return the number of fruits total. Okay, and the expected output is 3, as shown here. And the explanation, we can put 2 C fruits into one basket. They're from different trees, but the types. We can put 2 C fruits and 1 A fruit in another basket. Okay, so our dictionary would look something like this. We'd have A at 1 and we have C at 2. Okay, now how would I get to this conclusion? How would I conclude 3? Well, I'd probably look at each character in the, what's it called? I'd look at each character in the frequency dictionary, and I'd begin to add things that didn't exist. So I'd do a quick check. I'd say if character in A, or I guess not in A. Say if character not in A, add it, and do I'll just add frequency again. Frequency at char plus equals 1. Okay, that's our window widening step. Now the window shrinking step, based on our last problem, is probably similar in that we're going to begin to try to shrink our window once we have greater than, not k, but 2. So once we have 3 different fruit types in our frequency dictionary, we're going to try to stop it. So I'm going to say while, length of frequency greater than 2. Okay, what are we going to do? Well, here's the thing, right? In our last problem, we did the max length calculation after. I think we did it after because we were checking for something greater than k. We're checking for a length greater than k, greater than 2. So after, I think, makes sense. If we go to another one, we checked inward because we could check for equal to. Not just greater than, but also equal to. So I think that's why. I think it depends on what your check is. But you can run the numbers and what did I just say? You can run your tests to see if it works. I wouldn't rely on like memorizing patterns, but truly understanding why you're doing something. Okay, so let's take a look. So we have our conditions. While we have a frequency, we have a count of keys greater than 2, we want to shrink our window. How do you shrink the window in layman's terms? You subtract from your starting character. So we point to probably A at this point. We're probably on some other character, but we're going to point to A. Actually, to hit this example, we're going to be, our end will be at C. We've just added C to the array, so we can actually draw this out right now. So I can say A as 1, B has a count of 1, C has a count of 1. Our start points to A. And what we say is we'll subtract 1 from our starting character, which makes it 0. And then if our starting character, is in there and it's equal to 0, delete it. So we're going to remove A. And so our count now, our length of our frequency dictionary is no longer greater than 2. At that point, we can then number one track for our maximum number of fruit, increment our start in the while loop, and then is that it? Return our max. That's the whole problem. Kind of nuts. Okay, I'm gonna write all that down. So starting character equals, I guess, S at start. Do a frequency at start character minus equals 1. If your frequency at start character index equal 0. If it equals 0, then delete it. Start plus equals 1. At the end of our while loop, we're going to update our max. And in this case, we'll run through the math ourselves, but it'll be a max function between our current max and end minus start plus 1, I believe. Our typical window size calculation, right? So let's take a look. Our end is currently pointing to index 2. I'll write the indices again because I keep forgetting or get confused during the testing. I don't really care for that right now. Okay, so we have index 2. Our start is now at 1. We're gonna check for a max. 2 minus 1 plus 1 is 2. So our current max length belongs to 2. That makes sense. But I can't tell if it's the AB group or if it's the BC group. I think it's always the previous one. So it's the AB group. We're out of the loop. Cool. Our start now points to B. We add the A back. It's an A1. We do our loop, pointed to B. We drop that. Now we just have A. Here's the fun part. No, that's fine. Yeah, okay, that's cool. We just added one more, so I think our last one will be 2. Our max length is still equal to 2. Our start now points to C, or now points to C. We added an A. We set up that pointer. Everything was cool. Cool. So we add our other C. This is a 2. Our length is not greater than 2. So there's no need to do any subtraction or deletion if we're at 0. After subtraction, we can now just say end is 4 minus 2, which is 2, plus 1, which is 3, which is our new max length. I like the fact that that works, thank God. In terms of other tests, let's take a look. I mean, if I come up with other tests, right, to see if our algorithm actually works, you'd want to have a test where, there's only like one type of fruit. Like it never repeats anything. So for example, we might write, A, B, C, D, E. Just get crazy with it, right? So we're gonna add an A, not greater than 2. We're gonna add a B, not greater than 2. I add a C, greater than 2. Our end points here, our start points to A. And our current length equal to, I guess, 0 at this point. We hit this, we're gonna subtract 1. Subtract 1 from the A. It goes to 0. We delete the A, general. Our pointer now points to B. Our max is index 2. Forgot to count for a second. Our max comparison is now between 0 and the evaluation of 2 minus 1 plus 1. That's 2. So our length is now going to be 2. So we're going to then add the the D. Our D is 1. We're going to get rid of our B. Compare our start and end, which would be 3 minus 2 is 1 plus 1 is 2. So at that point, I think the point is that pattern repeats, and we should return 2 from this. That should be a 2, okay? Excellent. They gave us another example that I think I like a little bit more. Okay. What did they give us? They gave us A, B, C, B, B, C. Okay. A, B, C, double B, C. Our start points to A. We add our A. We add our B. We add our C. We get rid of this. Wow, I almost licked my hand. Can you imagine that? So we're getting rid of the A. our points now goes to B. Our length now points to, I'll lumble this, 0, 1, 2, 3, 4, 5. It's going to be a 2 minus 1, which is 1 plus 1 is 2. Current length max is 2. Or I guess number of fruits in between our baskets, 2. Our N, we now add the B, that's a 2. We add the B again, 2, we add the C, or I guess B is 3, what? No, B is 3, it's 2. Okay, so we never got to another time when we had to update the dictionary. So our end at this point is pointing to, I believe, C, which is index 5, minus our start, which pointing to index 1. So 5 minus 4 is 3, plus 1 is 4. Now that's wrong. What did I say? 5 minus 1 plus 1 is 5. What did I just do? 5 minus 1 is 4, plus 1 is what? I said 3. 5. That works, okay. Let's code it up. I like these test cases, bro. Let's take a look, see. I need to first define our function. I like to do some typing when I write my test. I'll say fruits, which is a list of what? Strings. Okay, I'm gonna return out. We're gonna add our testing function. add a test array here. We're gonna say at pytest dot mark dot parameterize. We'll pass in some variables here. We'll pass in our fruits and our expected. There are tests also here. We'll define a testing function. Put our f and we'll put our expected. Point is to assert that the fruit to baskets with our f equals expected, and expected is a number. Ideally, I'll even type it. F is a list of strings. Okay. Well, like this code. One of our examples is going to be a list. Put A. Copy this. I'm quiet for some reason. I'm adding tests, and I'm also really. I shake my legs. I'm tired, so I'm rocking because I'm really exhausted today. I think that was 3. Also, I'm gonna add another one. My weird one was 2, right? Okay, my weird one. There should be one where with what? There should be another one with like all A's. So the size never gets bigger, but we will want to put 5 baskets in the fruit. Okay. That's not new. What else? Empty should be 0. 0 fruit. Suck on that. Okay, all these tests should basically fail. If I actually run the tests, test. Sorry if that's making a lot of noise. I'm really just so exhausted. Okay. Looks like we have 4 or 5 failures. Let's input our solution. So we have our start, our 0. We have our, I guess I'll call it what? I'll call it num fruit. What the fuck not? We'll call it frequency. Okay, we're gonna return num fruit for sure. So for end, I can also say just fruit. For fruit in fruits, which is why index is cool. Okay, yeah, I see why index is cool now. And you can just enumerate. Freaking Python. I can pull out the I can pull out the index and the fruit. Very Pythonic, sir. Good job. So, if fruit not in frequency, fruit frequency at fruit get 0, and frequency at fruit plus equals 1. Okay. I will say while the length of fruits or frequency is greater than 2, we're going to take our start character, which is just going to be our fruits at start, right? We're going to say frequency at start. So I say start character. It really should be starting fruit. So frequency at starting fruit minus equals 1. What else am I doing? If at the start fruit we have 0, then delete. I'm not talking because I'm really tired. Our start gets incremented. I'm going to up it our max, or what's it called? Number fruit gets max between num fruit and end. I should say I. Did I use I anywhere? I did not, except for here. That's my whole solution. Read it and weep, bitches. And everything passed. Oh my god, I'm a genius. Okay. That's all I'm doing. I'm out of here. I can't do this. I'm so freaking tired. I'm pushing to get out. Give me the problem. Okay. That's it. I'm done. Peace.